Welcome class to the review for Test 1. Unit Test 1 will be split over two tests. The first test will include the classification of matter, the separation of mixtures, physical-chemical changes, and significant figures. If you look on your unit outline, it basically includes the first 7 homework assignments. You can see that your unit outline provides text pages for your review, both Zundel and Highmark's chemistry review. So what we'll do for most reviews is we'll review your review sheet. So in all review sheets, there will be major ideas that are placed above some practice questions. Here are these major ideas. You'll want to make sure that you read over them and you're familiar with those key ideas. What we're going to do is we're just going to go step by step through questions, break them down, and make sure you understand how to approach them. Now, in question number 1, it asks, which substance can be decomposed by a chemical means? So I've underlined the keywords. Let's take a second to look at each of those keywords before we actually answer the question. Now let's recall that matter can be separated into pure substances and mixtures. Pure substances have only one particle type, while mixtures will have more than one particle type. Looking at the particle diagrams here, notice that in the 4 samples of substances, they're considered substances because each particle within the box is identical. So here is one substance and here is a different substance. And each particle, you can identify the particle because you can essentially circle it, is identical. Now, in substances, we have 2 separate kinds of substances. We have elements, which are over here. Now, elements only have one type of atom. In this case, atoms are pictured in different colors. Next, we'll look here at compounds. Again, compounds are pure substances because every particle is identical. You can circle each particle and they are essentially identical to one another within the box. But these are compounds and not elements because compounds have 2 different types of atoms that are chemically bonded. So we can see that they are 2 different colors. Now here I have examples of 2 different types of compounds. When the atomic ratio of atoms changes, the identity of the compound changes. So here you can see in the first example, I have a compound, we'll just call it Rb. And in the second compound, I have Rb2. So when the ratio of atoms changes, the identity of the compound changes. Now, elements, because they only have one type of atom, elements cannot be broken down in any way. Versus compounds, in order to decompose them or break them down, you actually must break a bond. So they can only be broken down chemically. Finally, we have mixtures. And in mixtures, notice that we have 2 or more different particle types. So in all of these examples, we have red and blue atoms, but they are not chemically bonded, so they're their own separate particle. There are 2 types of mixtures. There are homogeneous mixtures and there are heterogeneous mixtures. A homogeneous mixture is uniform throughout, and a heterogeneous mixture is not uniform. So notice that in the homogeneous mixture, you'll see a regular repeating pattern, versus in the heterogeneous mixture, there is no pattern and there may be even distinct layers or distinct chunks. I like to think of the mixtures like Dippin' Dots ice cream. So, for instance, if you had this flavor of Dippin' Dots ice cream, if you were mixing them, they'd be perfectly mixed, maybe a strawberry-blueberry mixture. Versus if you had the heterogeneous mixture, you're going to have spoonfuls that are going to be distinctly blueberry and spoonfuls that will be distinctly strawberry. There may be regions of mixing, but it won't be a consistent mix throughout. Since the individual particles of mixtures are not bonded, they all can be physically separated. Looking at your homework to make a little bit of review, we can see that in this example, every particle is identical. So this here is a substance. Now, because there are two different particle types, we have the open circles and the hatched circles, that this is actually a compound. Now, if we look at the next example, here we're going to have a very elaborate mixture, and we know that this is a mixture because we have this compound present. We also have this compound present, which is different and not attached. And finally, we have this element. Now I know there are two atoms, but since they're only one type of atom, it's still considered an element, a diatomic element. So this here is a mixture. Finally, we arrive back at the question that we were asking: which substance, that means element or compound, can be decomposed by chemical means? That means that we're looking for a compound. So at this stage of chemistry, you're not expected to really know compound formulas, but you are expected to know element formulas. So how are we going to figure out which of these substances are an element? Of course, your reference table. Let's take a look. So to approach this question, you want to refer to reference table S, which lists all the common element symbols and all the common element names. You want to look for all those species there. Elements will always be found here. Compounds will not. So looking down and comparing the list, I first see element number 36 is krypton. So here you can see it's krypton is element 36. So that cannot be decomposed by chemical means because it is an element. So we'll eliminate that choice. Additionally, we'll see that on the next page, element number 51, antimony, is also not able to be decomposed chemically, and element number 74 cannot be decomposed chemically either, tungsten. So that basically leaves our methane as our best choice. Moving on to question 2, that's which particle diagram represents one pure substance. Recall that a substance is an element or a compound, and pure substances have all the identical particles. So when we look here, we try and circle all of the different particles. We see that choice A only has one type of particle. So choice A is actually the pure substance. Choice B is not a pure substance because you can see we have two different particle types. Same with C and also with D. In question 4, we're looking for a substance that can be decomposed by a chemical means. Again, we're going to apply the same logic as in choice 1, and we're going to refer to our reference tables. Let's take a look. Looking at reference table S, we see that oxygen is element number 8, phosphorus is element number 15, and silicone is element number 14. So in this case, our best choice is going to be ammonia. You need to double check and read through all of the element symbols and make sure you don't find ammonia. The next question asks us to look for a compound, but only one compound in the gaseous phase. So compounds have chemical bonds. And the chemical bonds exist between two different atoms. So it cannot be choice A because those are only one kind of atom. Cannot be choice B because the compounds or the bonds here are between identical atoms. So this is actually a mixture of two different elements. So here we're between choice C and choice D. Notice that in choice D, all the particles are identical, versus in choice D, we have this compound and we have this compound. So the best choice is choice C. Finally, question 5, we see a particle diagram of atoms that are really closely put together, and it asks at 101.3 kilopascals and 298 Kelvin, which of these elements could this diagram represent? So the first thing that makes many students nervous is this information. 101.3 Kelvin on reference table A is considered standard pressure. Anything standard is basically considered everyday conditions. So under everyday conditions of pressure, and then this 298 Kelvin is essentially room temperature. If we use reference table T, we'll see that's 25 degrees Celsius. Again, room temperature. Which of these could be this element? So what we'll see is, looking at the particle diagram, we notice that this is a solid element. And when we look through the elements, we know that most of these are gases, except for this right here. Silver, which you can go and look on reference table S to confirm its identity, is actually a solid, and you should know that. That's general knowledge.